Hey there, grade 10s. Welcome. Today, we're going to crack the code on a topic that can feel a little tricky sometimes, circle theorems. So if you've ever looked at a circle problem with all those tangents and angles and felt a bit lost, don't worry, you are in exactly the right place.
All right, let's just jump right in. Take a look at this problem on the screen. You've got a circle, some lines flying around, an angle they give you, and another one you're supposed to find. I know, at first glance, it can look pretty complicated, right? Like, where do you even start?
But here's the deal. Stick with me through this, and I promise you, by the end, this problem won't just make sense. You'll have the skills to solve it without even breaking a sweat. So let's do it. So, how are we going to tackle that monster of a problem? Well, like any good puzzle, we have to find our key pieces first. And that brings us to section 1, unlocking the key theorems. These are basically the rulebook for how circles work. First things first, let's get a core definition down. What is a tangent? It's really simple. It's just a straight line that kind of skims the edge of a circle. The most important part to remember, it touches the circle at one and only one point. That's it. Now, that simple idea leads us directly to our first and maybe most important theorem, the tangent radius theorem. So check this out. Wherever that tangent line touches the circle, if you draw a radius from the center to that exact point, they will always form a perfect 90-degree angle. Every single time. This one is an absolute game changer. And if you want to make this idea really stick, just picture this. Think about a bicycle wheel sitting on the ground. The flat ground, that's your tangent. Now imagine one of the spokes going from the very center of the wheel straight down to the ground. That's your radius. See how they meet? They make a perfect T-shape. That right there is your 90-degree angle in the real world. Okay, on to our next key theorem. This one's called the two-tangent theorem, and it's also incredibly useful. So if you pick a point outside the circle and draw two lines from that point so they're both tangent to the circle, well, the lengths of those two tangent lines will be exactly the same. Kind of like an ice cream cone sitting on the scoop, right? The two sides of the cone are always equal. And I'm not kidding when I say this. These two theorems are pretty much your secret weapons. The first one gives you right angles out of nowhere, and the second one gives you equal sides. Just with these two ideas, you can solve an amazing number of problems. Okay, so we've got our tools. Now, the question is, how do we actually use them without getting all jumbled up? Well, that's where a good strategy comes in. Welcome to Section 2, the step-by-step playbook. Think of this as your 4-step game plan for any circle problem. Step 1, analyze and diagram. Don't just look at it, get your pencil out and mark up everything you know right on the picture. Step 2, identify the clues. Are you seeing tangents? Are you seeing radii? This tells you which theorem to grab from your toolkit. 3, connect and formulate. This is where you use the theorems to build a bridge, an equation that connects what you know to what you need to find. And finally, step 4, calculate and verify. Solve your equation, but then, and this is important, take a quick look back and ask, does this answer actually make sense? This playbook keeps you organized. Now let's be real. Even with a good game plan, it's easy to fall into a few common traps. So in Section 3, we're going to talk about the most common mistakes students make and, more importantly, how you can avoid them. Okay, here are 2 big ones. First trap. Just assuming any line that hits a radius is 90 degrees. No way. The escape. You have to confirm the line is a tangent first. Only tangents get that special 90-degree treatment. The second trap is mixing up your theorems, like using a rule for chords when you're dealing with tangents. The escape for this one is simple. Just pause and ask yourself, what am I actually looking at right now? And then pick the right tool for that specific job. All right, you've got the theorems, you've got the playbook, you know what traps to watch out for. I think you're ready. It's time to go back to that problem from the beginning. Let's head into Section 4 and solve this thing. So here it is again. But take a look at it now. It doesn't seem quite so scary anymore, does it? Now it just looks like a puzzle, and we have all the pieces we need to solve it. Let's walk through our playbook step by step. Okay, playbook steps 1 and 2. Analyze and identify. Let's look really closely. What are the facts? What did they give us? And what shapes and lines can we spot that might be clues? So let's list our clues like a detective. 1, we definitely have 2 tangent lines coming from that one point outside the circle. 2, we see 2 radii touching those tangents. And 3, if you look at the shape they make together, the center, the 2 tangent points, and the outside point, it's a 4-sided shape. It's a quadrilateral. This is our aha moment. It means we can use our tangent radius theorem for sure. And now for step 3, connect and formulate. Because of that tangent radius theorem, we know instantly that two of the angles in our shape are 90 degrees. And we also know a basic fact about any quadrilateral: all four angles have to add up to 360. See, we've just built our path to the answer. And this is the best part. That whole complicated-looking diagram, it really just boils down to this one simple calculation. We take the 360 degrees from the quadrilateral, we subtract the two 90-degree angles we found with our theorem, and then we just subtract the one angle they already gave us. And boom, there's our answer, solved. Just like that. We took something that looked really tough, and by using our theorems and our strategy, we turned it into simple subtraction. That's what understanding the rules can do for you. And that's really the big idea here. Geometry isn't about being intimidated. It's a puzzle. And once you have the right keys, like these theorems, you can unlock any problem they throw at you. And now you have the keys for tangent problems. So before you go, take a look at this new problem here. Based on everything we just talked about, what's the very first thing you notice? What's the first step you take to solve for x? See, you already know how to start. You've got this. Thanks for tuning in.